So far, we've been using Unity's built-in methods to achieve all the behaviors that we've wanted. However, simply using these built-in methods can often be very limiting and causes your code to be very long and confusing. It's often required for us to create our own methods so that we can group our code into blocks that make logical sense, and then reuse that code whenever we need it. Here in my scene, I have a boy game object. You might notice that the boy game object is in the upper left-hand corner, has an odd rotation and an odd scale. Let's say I wanted to create a script that had a method on it that whenever I called that method, whatever object that script was on was moved back to the origin, given the default scale and a default rotation. Doing so would be quite simple. I could put the code that I needed inside the start method like we've done in the past. I could say transform.position equals vector3.0. This is simply a shorthand way of getting a vector3 that has zeros for its x, y, and z values. I could also use a default rotation by saying transform.rotation equals quaternion.identity. Again, this is simply shorthand for saying no rotation, or Euler angles of 0, 0, 0 degrees about the x, y, and z axis. Finally, I could say transform.localScale equals vector3.1. That gives us a value of 1 for the x, y, and z variables of a vector 3. This would seem to do what we want, but like I had said previously, I want to be able to call this code whenever I want. Inside start, it's just going to be called whenever this object starts up. I could put these lines of code all around inside my script and all the various places I might want it to happen, but that would lead to what we would consider to be a maintenance nightmare. Anytime we decided that we needed to change one of these values, we would need to find all instances of this code and change it. That's not really a good practice. Instead, we're going to create a custom method that's going to contain this code. We can then call this method whenever and wherever we want. To create a method, the first thing we need to do is specify its return type. We'll talk more about the return type in a later section. For now, we're just going to say void. Then, we need to give the method a name. Just like variables, method names can be pretty much whatever you want. However, you can't use spaces or special characters, and you can have numbers, but they can't be at the beginning of the name. A common and standard practice is to start method names with a capital letter. Let's name our method initialize. Now, just like the start method, we see that we need some parentheses. Again, we'll talk about the parentheses in a later section. For now, we're just going to leave them empty. We finish by declaring our block by creating an open and closed set of brackets. Inside this method, let's place all the code we want to be grouped together, specifically the code that is currently on lines 8, 9, and 10. Now we have our own custom method named initialize, and we can call that method whenever we want. We could, for instance, call it from the start method. To call a method, we simply say the name of the method, plus the open and close parentheses, followed by a semicolon. Now, when our game object starts up, the start method will be called, and the first thing it will do is call the initialize method, which will then run through lines 13, 14, and 15, and reset the position, rotation, and scale of our game object. To demonstrate even more how this is useful, let's use the update method. In addition to the update method, let's use a Boolean variable called shouldInitialize, which will allow us to say within the inspector that we want a game object to go back to the default position at runtime. Now inside the update method, let's see if shouldInitialize gets set to true, and if so, let's call the initialize method. Also, we should be sure to set shouldInitialize back to false, otherwise we'll call the initialize method every single frame. Let's go ahead and test this out. In Unity, we'll hit play, and we'll see that the boy game object gets moved back to the origin with no rotation and a scale of 1, 1, 1. We can then, while the game is running, move the boy around, rotate it, even give it some scale. That certainly looks like a disaster. We can now call again the initialize method simply by checking the box should initialize. We'll see that should initialize immediately becomes unchecked again, and the initialization method runs, and our boy game object moves back to the origin with no rotation and a scale of 1, 1, 1. This really only scratches the surface of the things we can do with custom methods. One more thing that's worth looking at is the access modifier of methods. So far we haven't really looked at this. We know that if we declare a variable as public, it's accessible to scripts outside of this class. The same is true for methods. All methods are private by default, but if we specifically say a method is public, in this instance public void initialize, that means that this method can be called from other scripts. Other scripts that have a reference to this script can call the initialize method for us. That doesn't make a lot of sense for our initialize method. However, it's worth knowing that you can do that, as you'll see that happen a lot inside the Zombie Toys code.